And now it is my great pleasure to introduce our keynote speaker, the legendary co-founder of Apple Computer, Steve Wozniak.
Thank you very much for your warm reception. I'd like to apologize in advance for a sore throat. It seems that a virus has hit me. I come out here today to Boston, where I've got a lot of good computer friends. Some of the finest people in our business have come from here. I come from Cupertino, which is the home of the greatest revolution of our times. I grew up in Silicon Valley, home of transistors and integrated circuits is why it's called Silicon Valley. And there were a lot of electronics parents, a lot of electronics kids. We read Tom Swift books, stories like the Hardy Boys, except it was about this inventor named Tom Swift, who had his own company, who had his own laboratory. I would sit there reading these books about how ingenious he was and how resourceful he was to solve any problem in the world, to build any device that was needed to trap aliens from outer space or to send anti-earthquake pulses through the earth. Would read these stories by moonlight after my parents made me turn my own lights off. So Tom Swift was our hero. A lot of times when you're very young, you read a book and it kind of gives you inspiration. The heroes you identify with lead you on your path in life. Read a book in about 5th grade called SOS at Midnight about a guy who had a ham radio license. And he was in high school, and a bunch of his friends would get on the air every Tuesday night at midnight and send messages back and forth in Morse code with telegraph keys, beep, 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 beep. He got kidnapped in the book. He was able to rewire the kidnapper's TV, build a transmitter, transmit a message to his friends, and they were able to come and rescue him. Went to school the next day and told my friends, I'm going to be a ham radio operator. And sure enough, by 6th grade, I had a ham radio license. A lot of these little directions, things like science fair successes and all, kind of determine your direction in life. And it all happens when you're young. Most teachers tell me that it's like around by 3rd, 4th grade, they can tell which students have decided to kind of be dropouts and always act like school's not important and I'm too tough for this, and which ones are really bright and they want to learn and they want to study and discover new things. My friend Alan Baum was my only friend. He went off to MIT and would ship me manuals from the courses he was taking, and I would read all of his books, and I learned a lot that way. He told me there's a club starting for people who have terminals and things. I said, great, I just designed a terminal. I can go down to this club and tell everybody I've got a terminal of my own design, a video terminal. I didn't even know that there were a couple of other people designing video terminals back in that date, like Don Lancaster, who had the TV terminal, which was a hot product in the hobbyist community, because I'd gotten out of the electronics hobby community. I didn't read their magazines. I didn't know that what a microcomputer was. I didn't know what a microprocessor was. I didn't know that a microcomputer had recently been introduced that was spurring this thing to happen. If I had known that the first microcomputer club in the United States was about to start, I would have been afraid to go because I was very shy and scared of kind of unknown territory. I would have skipped it. But my friend lied to me and told me it was a meeting for people with terminals, so I went. 20 people met in a dark garage with the rain dripping outside the garage, and Gordon French's garage, he stood up front and explained what these upcoming computers were and why the 8008 microprocessor might still have a lot of value, even though the 8080 was superior. And other people got up and started talking about this 8080 chip that I'd never heard of, and how a company out in New Mexico had built it into a cheap computer that people could buy and build it as a kit. You would buy it as a kit, get all the parts, you'd stuff them in boards, solder them together, bolt transformers in place, screw the whole thing together, put a front panel on, solder wires to switches. You had to be a technician to build it, but when you were done, you had a computer. Couldn't do one useful thing in the world, but it was a computer. And there were a lot of people that were going to want this kind of thing even before they could use it for anything. They started talking about these products at this homebrew computer club, as it became known as later on. And I sat there feeling very sheepish. How do these high school kids and how do these grandparents know all these things that are going on? And they know mnemonics and codes and processors, and I don't even know a thing about this. So I was very sheepish, but I took a data sheet home with me that night, and I studied a microprocessor chip, and by morning, I knew that a microprocessor was just like a mini computer, except it was smaller and all on one chip. But it had the same kinds of instructions and the same kind of computer logic, and I had studied these things and designed my own and built them, and I knew what they were about. I had written a lot of software for them, even though I never had one to run it on. So this changed my life quite a bit. I decided to get back into computers. And I knew that now I was going to actually own my own computer like I had promised myself when they cost as much as a house. That now I could afford it, especially if I built my own. It was very difficult to come up with $400 in 1975, which is a lot more of today's dollars, to buy a little computer that kind of has 256 bytes of memory. And then you've got to spend another $400 for some memory, and another $800 for a terminal, and another $800 for BASIC. I didn't have this kind of money, but I knew that at least if I built the computer myself, I could get a lot of the parts for free. And I already had designed a video terminal, which could be the heart of a computer. The first thought that occurred to me was all these other computers are big old boxes with a flat square metal plate and a bunch of toggle switches on them. And that didn't seem right, because here I had a video terminal, and it was so convenient to call big computers in Boston and run programs on them with this terminal. And so I came up with the idea in my head that the right paradigm for a microcomputer was a terminal, a keyboard to enter information in. And you could start typing if you had a small program like we had in our calculators, a small program that when you turn it on, it starts looking at the keyboard and says, what key gets pressed? You press the 5 key, and it goes off and it tucks a 5 into memory somewhere, and maybe displays it on a screen. And then it says what key's going to get pressed, and you press a 6, and it does something with the 6, and you press the return key, and that means go do something. If you write a little program in ROM memory, non-destructible memory, and you deliver it with the computer, it took many fewer chips and much lower cost to read a keyboard in than the huge number of chips you had to put in to operate with a front panel anyway. This kludgy front panel where you had to toggle strange binary numbers on switches took more chips to get into the computer and make the computer operate according to when you push buttons on the panel than if you simply had a keyboard that could send commands directly into a program that would do it for you. So the idea was a computer should look like a terminal. It should have a keyboard and a TV screen. And of course, I was into what would I use a computer for? Well, there were two obvious things. When you went to open house at Stanford Linear Accelerator Center or Stanford this and that or any other computer place, what did they show on computers in 1975? These big, huge machines, that there was a computer elite, there was a mystique about them, nobody could have their own. What did they show to families on open house day? Games. And of course, at my homebrew computer club, there was a flood of books showing games written in BASIC. And this was going to be the accepted default standard for microcomputers at its start. So I knew that first of all, I wanted to be able to run games written in the BASIC language. Also, I had certain types of computer design problems that I did for Hewlett-Packard for my job. And I wanted to be able to implement those programs and run the ones that would help me in my design work. Well, the Homebrew Computer Club, I was starting to spin ideas of what I would do with a computer, and I knew I was going to build one, but there was one problem. The heart of the computer, the microprocessor chip, cost $400. That's like $1,000 today. That's a lot to pay for one chip that's the heart of your computer. You're not likely to do it if you're just on your own and you got holes in your jeans and that's all you wear and you're just a long-haired technician kind of at work. So I wasn't going to go down to some weird little distributor who wants me to sign up on all these sheets that make it look like I'm setting up an account. And I'm giving information about my bank, which generally has $20 in my account. And it's a strange world. When you're used to buying things, at the grocery store over the counter, you don't feel comfortable. You're not a businessman. You don't know what these accounts are all about. So it was very difficult for someone like myself to buy a microprocessor. Well, a company called MOS Technology got started, and they introduced a microprocessor called the 6502 in such a way that in San Francisco at an electronics show, they would sell it over the counter for a $20 bill. And this was a remarkable marketing coup, and a lot of my friends from Hewlett-Packard, a lot of friends from the computer club who couldn't afford one before, went down and bought that $20 chip, and that's how we chose it. And it claimed to be the best chip of its day anyway, which I still agree. The personalities of our computer club. It was the first one in the country. Some of the key leaders, including our eventual meeting conductor, Lee Felsenstein, and Robert Riley, and some others, they had come from a background of leading anti-Vietnam War demonstrations in the Berkeley area and Oakland area. And they had come to discover that they needed a better way to network people and have communication tools. And they envisioned the computer as the eventual solution, the way that people could, via electronic bulletin boards, leave messages and I need this, and eventually expand their database and their knowledge. And they wanted to organize this kind of operation. They saw computers as a socialization tool. Others of those who founded the company saw it as a technology-changing tool, and we were going to revolutionize the world and turn the tables upside down on companies that pretended that computers were big and enormous and beyond our understanding. Now we realize that young children in school, young 8-year-olds and 10-year-olds, were going to be writing better programs than their parents, and suddenly discovering that, hey, computer isn't that much of a mystique after all. It's really simple, and anybody can do it. So Lee Felsenstein would conduct the meetings. He did a very good job. Organized us into mapping periods where people would raise their hand and say, does anyone have this sort of thing? This is what I need, a type of chip or an interface schematic, or know how you fix this problem. Other people would raise their hand and say, I've got some RAMs for sale today, $2 each, or I've got some manuals on this, I've got a certain type of teletype for sale. People would offer things, and what you'd do is if somebody offered something you needed, you'd look at them, raise their hand, you'd see who it is, and you'd meet with them later during the random access period. If someone needed help on something and you could offer help, you'd go meet with them during the random access period. And we were all there to help each other see what this revolution was all about. And we used the word revolution very openly. All the companies, everything that was printed in the financial sections of the newspapers in 1975 said, it's a bunch of kids driving around in beat-up VW vans. This thing's never going anywhere. These computers don't have a marketplace. It's just a little fad, for the hobbyist community. But we started realizing that people were going to have computers in their homes, and that it was just starting, and that the big companies didn't see it. Jim Warren came to our club meetings, and he had some experience with a company called People's Computer Company, involved a lot in getting educational software out to the masses. And he had rumor after rumor after rumor, every single tidbit about what company was going to come out with this product, and so over there, this executive was leaving to join some other firm, a new microprocessor was about to be introduced. He always knew every tidbit of information weeks before we normally heard it. So half of the meeting was consumed listening to these interesting little tidbits about the industry that was evolving from Jim Warren. This was the most important. Every 2 weeks we met, Wednesday night, 7:30 p.m. This was the most important every 2 weeks of my life, to get ready for this meeting and to hinge on every word and listen, because I was too shy to ever raise my hand and speak myself. I was not really a participant yet. My friend Dan Sokol, whom I met there, would go up to the front of the auditorium sometimes and say, is there anyone here from Atari? No hands would go up. He'd say to 500 people, he'd say, well, I've got some chips from a Pong game they're going to come out with for their home, and it's not quite on the market yet, but we're going to auction them off. We had there was kind of a pirate aspect to it. Nothing ever seemed wrong to us. Later on, the people who eventually formed Microsoft introduced the first BASIC for these small computers. You buy the computer for $400, you buy the BASIC for $600. Doesn't sound very efficient. Okay, this is from Bill Gates. Well, Dan Sokol took a copy of it on paper tape that you could read in with a big, huge teletype, took it home, came back with 20 copies. Okay? And the rule of the club sort of became, anything you take out of the library, you have to bring 2 or more back. Randy Wigington was a high school kid who eventually became very important in Apple's early history. And although he was just in high school, he was sharp, he was at the club, he had a lot of good questions and comments, and I met him there. And he would help me carry my big Sears TV in and set it down on a table where I could demonstrate my computer work as I started designing computers for the club. Randy was in charge of running a chat program on a local time-sharing company where people with terminals could all call in and talk to each other, much like today's forums, much like, even forums on the new Apple link. Well, I discovered that this program that did this chatting used a file. I read the program written in BASIC, used a file called ChatX to pass the information one person was typing to everyone else that was listening. So I wrote a program of my own that sat there in a little loop and said, is ChatX free? Is ChatX free? As soon as it was, grabbed it and dumped 14 pages of Pollock jokes into it. Another youngster I met at this club, Chris Espinosa, became very important in Apple's history, going way back to its earliest days, before we even started, right on through today. He still works at Apple, one of our longest term employees. We were about to come out with the Apple II in an eventual year. I'll skip ahead and tell this. The Apple II, and Chris stayed all night with me writing the first demonstration program ever to use high-res color demonstration program on the Apple II computer for a magazine article so we could get some pictures. So we stayed there till 2, 3, 4 in the morning making little changes to it to swirl lines around on a screen. Chris went home kind of late. You know, he lived down the street. And his mother got so upset at him coming home that late, because he was only like 15 or 16, that she wouldn't let him come to Apple for a long time. Most of the people in our club were very scraggly. They weren't dressed certainly in suits. They weren't managers. They weren't the people who even had good access to computers. They were the ones that wanted computers of their own. They were all technicians. Very few of us could afford a computer. After about 1 year of the club operating, with every single person out of 500 gonna own a computer, only about 5 to 8 of us had our own computers yet. The newsletter, we had a newsletter. People would give little program listings. Here's how you can write a program to calculate a random number. Here's how you can write. They were very simple, trivial programs at first, but it inspired others of us to believe that anything you do has value if you want to share it. So I started writing programs and sharing them through this club newsletter with other people, or handing out my own schematics or my own programs so that other people could build their own projects. I handed out schematics of my terminals. Eventually, when I built the Apple I, I handed out schematics of that. Went over to people's houses and helped them build their own. We believed that there wasn't any money in this. This was not a business. We were doing it for the love of technology, and we were changing the world. And this was just our little step on the way.
It is my great pleasure this morning to introduce to you Del Yocam, Executive Vice President and Chief Operating Officer of Apple Computer. He is the man responsible for guiding Apple's day-to-day operations, including advanced technology, product development, worldwide sales, marketing and distribution, worldwide manufacturing and operations, and information systems and technology. It's quite a handle. Since joining Apple in 1979, Mr. Yocam has been a major force in its growth from a young startup to a $3 billion plus corporation. From its inception, Apple has been a company with a passion to change the world, a passion driven by a vision of the vast potential of the human mind. We're here today to see and to celebrate the creativity and innovation which are the fruits of that vision. We're very pleased to have Del Yocam, a man who helped make the Apple II the leading computer in schools around the world, a man who helped open up the Macintosh to be more accessible to developers, to open our festivities here today. Mr. Yocam is here to share with you some thoughts about the past, how far we've come, and the future, the challenge of what can be, how computers can change the way we work, think, and learn, and how the relationship between people and their computers can truly change the world. Ladies and gentlemen, Mr. Del Yocam.
Thank you, and good morning. From the moment the first Apple I was built, our company has been immersed in change, driving the process of change, driven by a belief in the possibility of real change in the world. About a year ago, a few of us at Apple sat down and tried to put down on paper exactly what the essential characteristics of our company are. I got to tell you, it wasn't an easy task. But after much inward and outward examination, we decided on the following 3 traits. First, that we make the best personal computer products, period. Second, that we create an exciting environment in which to work, to learn, and to communicate. And third, that we have a passion to change the world. Today, I'd like to talk about that third characteristic, our passion for changing the world, and how it's reflected in what we do at Apple. In fact, I think that third characteristic drives the first 2. Since that first Apple I was introduced, and over this last decade, the world has changed. Of course, we can't take full credit for changing the world, no matter how much we'd like to. But we'd like to think our products have at least shaken it up a bit. Personal computers have come a long way. From one machine that was built to show the homebrew computer club that some kind of personal computer was a possibility, to personal computers with the power of mainframes. And Apple has come a long way too. From a couple of guys in a garage with a questionable credit line, Apple has become, in 11 years, a Fortune 200 company with sales of $3+ billion a year. And Apple has also changed in other respects. We are now a company that belongs to a lot of people in a lot of different ways. We belong to our stockholders, to our employees, to our third-party developers, without whom nobody would have a reason to use a computer in the first place. But most of all, in a way that is recorded on no financial ledgers or stock tape or contract, we belong to the whole community of Apple users. That's what we're here to celebrate today, our community, how it's been changed by the personal computer revolution and the amazing achievements in personal creativity, productivity, and education that have resulted. Of course, much of Apple's early success is due to how we changed the way people could communicate with their computers. We thought that it should be as easy for people to get their computers to do relatively complex things, and we used innovative technologies to make that possible. Now, we wanted a task on an Apple computer to be so easy that even a child could do it. And as you know, several million did. So we've changed the relationship people have with the computer on the desk in front of them by making tools that allow people to concentrate on the task itself, not on the tool used to perform it. But as information becomes the dominant commodity, and the task we face in education, business, and in our personal pursuits become more and more complex, we've also begun to change the way Apple users communicate with other people. We've proclaimed 1988 as the year of networking and communications at Apple. And since the beginning of the year, we've witnessed a whole series of events which reflect that focus. Among them is Apple's introduction of a series of products that extend the power of the Apple Talk networking systems to the classroom. Products designed to give educators a simple but powerful way to communicate with each other. And we introduced the Apple CD-SC, our CD-ROM drive, to allow for quick access to high volumes of data, including text, graphics, and digitized music. So we've begun to change the way Apple users access information and communicate with other people. Now we want to extend that change to include the way that they can communicate with Apple itself. Up until now, users only wanted to communicate with computer manufacturers for one of two reasons. One, because they needed additional product information, or two, because they needed to have something fixed. That was about it. But we want to change that relationship. We want to go from being a source of product and support information to being a source of all kinds of information to enhance your experience on an Apple II. So we've introduced a product to help get that information to you with a minimal of hassle. It's called the Apple Link Personal Edition, an online service that allows you to communicate directly with Apple corporate offices, other Apple users, and information services. And we've made it available first on the Apple II product line. What Apple Link does is what Apple has always wanted its technology to do. It empowers individuals to explore on their own and to give them the opportunity to communicate and share their discoveries in a community. It's a powerful electronic mail facility. It enables you to sample new software. And with a live connection to all other online users, you can engage in a real-time chat or send each other instant private messages or flash notes. You can join special interest forums on any subject, from baseball to electronic music, or you can start one yourself. The possibilities are limited only by your imagination. You can listen to special guest speakers like Steve Wozniak in the online auditorium. And you can get online news, shopping services, continuing education, and many other services. We believe it will transform the relationship of Apple's users to Apple and to each other. After all, if two heads are better than one, how much better are the combined powers of over 5 million, each of them supported by an Apple computer? Changes in work styles and changes in communications that make information more accessible and useful are all significant. One of our primary research projects is the Apple Classroom of Tomorrow, or ACOT. And of all the research efforts we have going on at Apple, this is the one that's closest to me in spirit. When I want to get a glimpse of what education might look like, when I want to see some of the innovative ways computers might augment learning in the future, I go to one of several ACOT sites across the country. In its first phase, ACOT was designed to answer a relatively simple question. How would education change if everyone had access to computers 24 hours a day? But now, in its second phase of research, we're asking a much more subtle question about the relationship of computers to education. Exactly how can computers best be used to better the shape of the learning process? This is a vital question, not just for us, but for American education. And we're going to have to keep asking it if we're going to develop the hardware and software and communications technology that will meet the needs of students and educators in the coming years. We've set up model classrooms across the country, cutting across regional and economic boundaries. And we gave each student a computer to use at school and one to take home. And then we listened. We listened to what the students and what the teachers had to say about the experience and how computers were changing the way that they learned and the way that they taught. Here's what some of the students at an Apple Classroom of Tomorrow in Memphis, Tennessee, have to say about how they learn.
I pledge allegiance to the...
In many ways, the Apple Classroom of Tomorrow is very familiar. Children still read books, still use paper and pencils, still listen to the teacher, and still love recess. But something else is happening in these classrooms. Something a little like magic.
It's a wonderful experience having a computer. And the joy of it is you can do almost anything you want to do. It's fun. What I like it because we get to take computers home and we get to work on computers at school.
I really had a chance now to do things that I'd never done before.
It just feels great to be in this class.
It's like living up high.
The children are no longer feeling that they are confined to what the teacher constructs. The computer has released them academically. They work with the assignments that she's given them, but frequently I find them when I go up to check on the class branching out on their own to look at some other components. What it's done is it's tapped that ability to go in and say, I can learn some things by myself. I'm willing to listen to what you're doing, but here, look at this computer. It lets me go on without you.
Can you plug your telephone cord into the into the phone, like this the phone and this the modem?
I feel good because I like working on computers and I like working with the modem at home and getting on the bulletin board.
When we get on the modem, I think that's terrific because when you get on, you can write letters or messages to someone. You communicate through the computer. And we have another diskette that the teacher gave us in the first of the year. We can communicate with each other. Like I can call my friend and tell I feel ready to connect with her on the computer. And we can write. And whatever I write will end up on her computer.
The modem is I think it changed my life because you can talk through the computer to a friend.
He feels like this is a great adventure for him. ACOT class, that said something. It said something, and he heard it. He can hear what it's saying. You got a chance. You got a chance in life to be whatever you want to be. And it's just giving him so much motivation. You know, he's really enjoying it. There's no problem with him going to school and love to come home. So he can come home and get on his computer here. I am very excited to know he is into something that he's happy about. He feels good about it. Very good about ACOT. And I'm not in the class, and my husband. Oh, gosh. Now, that's a different thing, because both of them, they be fighting to get to the computer. My husband, believe it or not, my husband has taught himself to read by that computer.
Investigating how the computer can be used to extend learning from the classroom to home is a vital part of the ACOT project. Students are encouraged to use their home computers for classroom assignments, for mastering subjects and skills, and to explore the potential of the technology on their own. It's an exploration that involves the entire family.
It makes me feel more confident because I know most people in Tennessee or the United States don't know how to use a computer, and they're grown people. And I'm just a boy that's 10 years old, and I already know how to make my own diskette. They say your brain is sort of a computer, but my computer is sort of like a brain to me.
I could be a doctor, lawyer. There's a lot of things I want to be.
It's improved my style.
But with all of this talk about change, we don't want to lose sight of our roots. We believe that we've been able to lead the computer industry into this area of benevolent change because of the unswerving support of the Apple community, the users, and the developers. We see a future full of change, but we know that one thing will always remain constant. We know that you will be there with us. We haven't been able to make it without you in the past, and we figure we won't be able to make it without you in the future either. So I look forward to seeing you there. Thank you very much.